Okay, so this is the test review for Pythagorean theorem. Remember, guys, the Pythagorean theorem, you're going to have a squared plus b squared is equal to c squared, where a and b are the two shorter sides of the triangle, and c is the longer side, or what we call the hypotenuse. So when we set these problems up, if it wants us to find the hypotenuse, like number 1 here, you take the two smaller sides, and you would go 4.7 squared plus 5.4 squared, and set that equal to the longer side squared. And you will need a calculator for this. So you would go 4.7 squared plus 5.4 squared. So 4.7 squared is going to be 22.09, and 5.4 squared is 29.16. Add them together, and you would get 51.25. And that is equal to x squared. Now, what does the problem want us to find? It wants us to find x. So we're not quite there yet. We have to undo the square. So to undo the square, remember, opposite action of a square is the square root. So you're going to end up squaring both sides, and the square root of 51.25 is 7.1589. I'll just round that up to 7.2. So x is equal to 7.2. And then on number 2, remember the Pythagorean theorem is a squared plus b squared is equal to c squared. Here it gives us the longest side, and we have to find one of the short sides. So I'm going to set this up. I'll call this side my a, so x squared plus 10.7 squared is equal to 12.3 squared. So again, on your calculator, square those. 10.7 squared is 114.49, and that's still plus x squared, and that's going to equal 151.29. Now, because we want to solve this is a normal equation where we want to get the variable all by itself. So because this is adding, the opposite of addition is subtraction, we're going to subtract 114.49 to each side. And 151.29 minus 114.49 is going to give me 36.8. Now I'm still not quite done, right? Because I still have the square. So to undo the square, I square root it. And the square root of 36.8 is 6.06. I'll round that up to 6.1. Okay, and that's all you're basically doing. You're going to identify the longest side of the triangle, and that's what you're going to set these equations equal to. The other two sides, you add them together and square them. Okay, over here on this section, it gives you two sides, and it wants you to find whatever side isn't given. So like for instance on number 8, it gives me the length of B and C, so the missing side would be A. So I don't know what my A is, but I can solve it using the Pythagorean theorem, because A squared plus B squared is equal to C squared. So set that up, I'd have A squared plus 5 squared is equal to 11.1 squared. And then I would square those, minus it, and solve. Okay, that's what you do on that section. Then down here it wants you to state the triangle is acute, obtuse, or right. So remember, guys, with acutes, if the two smaller sides squared are greater than the longest side squared, it would make it acute. If the two smaller sides squared are less than the longer side squared, it would be obtuse. And if they're equal to each other, they're right. So let's do number 16 as an example here. To start these, I'm going to identify my longest side first. So 16, the longest side is 70.7 right there. So I'm going to set this up like I was going to solve for each side using the Pythagorean theorem. I do 14 squared plus 70.3 squared is equal to 70.7 squared. And then I just square those and add the two together on the one side. So 14 squared is 196. 70.3 squared. Oh. Here. So, sorry. 14 squared is 196. 70.3 squared is 4,942.09. And 70.7 squared is 4,998.49. So if I add those two together, 4,942.09 plus 196 is going to be 5,138.09, and that's equal to 4,998.49. So which side's bigger? The two smaller sides, which would mean that this is an example of an acute triangle. Okay? So then on the other side,
it's my turn to explain. So on the top of the next side, we're going to be doing the same thing. Find if the three side lengths form acute, obtuse, or right triangle. So we need to circle the longest side first. I'm going to do number 19. And the longest side I have 24, 59.4, and 62.4. My longest side is 62.4. So that's going to be my C, or my hypotenuse. So I take the two sides, 24 squared plus 59.4 squared equals 62.4 squared. And you'll want to use a calculator for this. 24 squared is 576. 59.4 squared is 3,528.36. And 62.4 squared is 3,893.76. So now if I add these two together, 576 plus 3,528.36, that gives me 4,104.36. And on this other side over here, 3,893.76.
it's another
So
acute triangle.
again, we can see that the hypotenuse is smaller, and if the hypotenuse is smaller than the legs, it's an acute triangle. So that one is also acute. Again, remember, if the hypotenuse was a bigger number, it would be obtuse, and if they were equal to each other, it would be a right triangle. Okay, so moving on to the next section. This section says, state if the three numbers can be the measures of the sides of a triangle. In class, in order to find the equation for this, we use the spaghetti noodles. So if you remember spaghetti noodles, you'll remember if you take the two small sides and add them together, so A plus B, it must be greater than C in order for it to form a triangle. So let's look at number 23. We're going to find our hypotenuse first. The biggest number here is 245, so that's going to be my letter C. I'm going to add together the two sides, 181 plus 63. If we add those together, 181 plus 63 equals 244. And then on this side, we have 245. 244 is not bigger than 245, so this is not going to make a triangle. It'll be no. Okay, let's look at the very last section. On the last section, we're just finding the distance. So I'm going to do number 27. On 27, 28, 29, and 30, if you would like to, you can count the boxes and use the Pythagorean theorem. So I'll do that first, and then we'll work with the distance formula. So in order to count the sides. You need to first make a triangle. So you make a right triangle by connecting the two dots. Then you count the boxes on each side. On this side we have 3 boxes, and going across the bottom we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 boxes going across the bottom. That last one's a little bit hard to see, but make sure you count all of the boxes that it's crossing. Okay? So now we know the side lengths are 3 and 9. We want to find the hypotenuse. So we'll go 3 squared as our A plus 9 squared as our B equals our unknown C squared. 3 times 3 is 9, and 9 times 9 is 81. So 9 plus 81 will be 90 equals C squared. Now don't forget the last step. We don't have C by itself yet. In order to get C by itself, we have to do the opposite of C squared, which is the square root. So we take the square root of 90, which is 9.48. Because it's 4/8, we're going to round it up to the nearest tenth, 9.5. That's what it says to do in the directions, round to the nearest tenth. So the answer is going to be 9.5 on number 27. Okay? Now, the distance formula is listed right here for you, so if you forget what it is, you can just look up to the top of the page. But let's go down and let's look at number 32 on the distance formula. So the distance formula, I'm going to rewrite it right here so that you can see it, is x2 minus x1 squared plus y2 minus y1 squared. So we want to take our x's and subtract them. Remember, the x's always come first in your coordinate pairs, just like in the alphabet. So we have 60 is our first x and 46 is our second x. So we're going to do 60 minus 46 squared plus, now we want to look at our y's. Our y's are 15 and 26. So 15 minus 26 squared. Now we need to simplify. 60 minus 46 is 14, and 15 minus 26 is negative 11 squared. Okay, now we need to do our exponents to simplify even further. 14 squared is 196. I'm going to write it out here to the side. So 14 squared is 196 plus negative 11 squared, a negative times a negative is a positive, so it'll just be 121. If we add those together, 196 plus 121, we get 317. And if we do the square root of 317, our answer comes out to be 17.8.
Nice.